Alright guys, so today we're going to be starting a concept called completing the square. And we're going to be talking a lot too about these square roots that we've been dealing with. This shows you a visual representation of how you can complete the square. I think it's a little bit confusing to look at it like this, but here's the way that we always complete the square, is we're going to take half of this term. So whatever the coefficient of x is, we're going to take half of it, and then we're going to square it. So if I give you a value like x squared plus 6x, what is half of 6? And then square it, and what do you get? So if I put this, if I add 9, this should now be what we call a perfect square trinomial. Because let's factor this. What times what would give us x squared? And then what times what would give us 9? And what would the signs need to be for the outers and inners to give us positive 6x? And so now if we have x plus 3 times x plus 3, that's x plus 3 quantity squared. Do you guys understand why that would be written that way? Okay, let's practice a few more of these. Suppose I give you x squared minus 8x plus 16. And we have to factor this. So if we want to factor this, we set up our double parentheses. It's going to be x and x. What numbers multiply to be 16 and add to be 8? 4 and 4. What do our signs need to be? Minus and minus. So this whole thing ends up being x minus 4 quantity squared. So we want to be able to do that really quickly. Let me give you another one. See if you can come up with that pretty quickly. Anybody know what it would be? Yep. Right. Everybody get that? Do you notice how if you take half of 10, what do you get? Square it. See how that pattern works? If you take half of 8, what do you get? Square it. Okay? So if that pattern holds true, you should be able to do the problem very quickly. Let's do one more. What is it, Marilyn? You got it. Okay? So that's the kind of thing we're going to be looking at, is we want to get these perfect square trinomials. So now let's come down here. Solve the equation using square roots. So we want to look right here, and we want another name for this. So what is another name for this? X plus 2 quantity squared, right? See how if I take half of this and square it, it's 4? So that means this is a perfect square trinomial. So I do, if you need to write it all out, you can. Let me show you writing it all out. What times what is x squared is x and x. What times what is 4? 2 and 2. I need a plus and a plus to get the positive 4x equals 2. Well, now I want to write another name for this. So another name for x plus 2 times x plus 2 is x plus 2 quantity squared. So now how would I solve this problem based on what we've already learned? Take the what? Let's take the square root of this and the square root of this, and we're going to get x plus 2, because if I take the square root of something squared, I just get whatever's under that square root. What do I have to put here? Plus or minus radical 2. And then to finish this, to solve for x, what do I do? Subtract the 2. And so then we're going to get x equals plus or minus radical 2 minus 2. Now, the way that they'll probably want you to do it on big ideas is they like to put this real part first and this irrational part second. Just like we do with imaginary numbers. The real part first, or in this case we can just, both of these are real. I should say the integer part first and then the irrational part second. Okay, and this is our best answer right here. Lots of 2's. All right, let's try this one now. This one is a little bit harder. Let's do it in 2 steps. I'm going to set up my double parentheses. I still have my negative 18. What times what is going to give me 9w squared? 3w and 3w. What times what is going to give me 1? 1 and 1, right? Now, when I check my outers, I get 3w. When I check my inners, I get 3w. And I want to get a positive 6w. So what do I want the signs to be of these 3w's? Plus on both. So now I have 3 plus w and 3 plus w, so that's the same thing as 3w plus 1. I said 3 plus w, I mean 3w plus 1 squared equals negative 18. What would our next step be? Take the square root of both sides. So I'm going to have, if I have the square root of something squared, it's just going to be 3w plus 1. Can anyone tell me the square root of negative 18? I'm going to have to think of that as negative 1 times 9 times 2. What's it going to be, Josh? Right, so it's going to be plus or minus 3i radical 2. Now, we're still not finished. We're trying to solve for w. What are we going to have to do to finish? Subtract the 1. Okay, so now I've got this, 3w equals, remember how we want to put the integer part first and then the radical part second? So we have this. This is a tough problem, but we're almost finished. We want to get w by itself, so what do we have to do? Divide by 3. So I can write it like this whole thing over 3. That's one way I can write it, is to put this whole thing over 3. But I have terms here. This is my first term. This is my second term. So I could also write it like this. W equals negative 1/3 plus or minus I radical 2. Let's pause for a minute and see how in the world I got that. These are the same answers. So what I did was, this is one term, so I put negative 1 over 3. This is my other term. So how did I go from this over this to just that? What happened to these? The 3's canceled out, didn't they? So that was how I got that term. But you have to remember that this term is getting divided by 3 and this term is getting divided by 3. Typing it into big ideas will be a lot easier this way, I think, than that way, though. So that's why we go that extra step. All right, let's keep going. All right, so in the next part, it says, find the value of c that makes the expression a perfect square trinomial. Then write the expression as the square of a binomial. Okay, so does anybody remember that pattern to figure out what this c value has to be to make it a perfect square? Sarah?
Divide 14 by 2 and then square.
Okay, so I'm going to do 14 divided by 2, and then we're going to square it. So what's it going to become, everybody? 49. So it says find the value of c. So c is going to be 49. Now we're going to rewrite it. It's y squared minus 14y plus 49. If you need to, you can write it out twice. What times what is y squared? Y and y. What times what is 49? 7 and 7. We get a 7y and a 7y, and we need it to be negative 14y. So what's it going to have to be? Minus on both. And so then I write this, it says write the expression as the square of a binomial. Well, here is the square of a binomial. Make sense? All right. Getting more difficult. Look at the next one. We already talked about what we have to do with this. We have to take half of 17. Now, 8.5, 8.5, we're not going to do that. We're taking half, and I'm just writing it as 17 over 2, and now I'm going to square it. I'm going to leave it as 17 over 2. All I have to do is square 17 and square 2. Does anybody know offhand 17 squared? 289. Over what? 4. Now, here's what our problem becomes. S squared plus 17s plus 289 over 4. And we have to factor that. We look here first. What times what is s squared? S times s. Think about it, guys. What times what is 289? 17 times 17, we just did it, right? So that's going to have to be 17 times 17. And then how do we get the 4? What am I going to have to do? 17 over 2. And then what about the signs? Should they both be negative or positive? Positive. Plus and plus. So here's going to be our binomial squared. Okay? Questions? All right, let's go on to the next part. We're now solving by completing the square. So to solve by completing the square, here's what we're going to have to do. This is going to be, you really want to focus on. We have to take this number over to the other side. So now I've got r squared minus 6r. I'm going to leave a space here, equals 2. So the first thing we always do is we take the constant to the other side. Now we're going to have to do b over 2 squared. This is b. B is this coefficient. If I take half of that, what do we get? And square it. Now, if I add 9 to this side, what am I going to have to do to the other side? Add 9 to keep it equivalent. Because now it's the same thing as what I started with. I added 9 here, so I add 9 here. So we have to find this and add it to both sides. All right, so we did that, and now we just finish. Here's how we finish. What is another name for r squared minus 6r plus 9? I can go the long way, or hopefully you're getting the hang of it, and we can go quick to what the answer is. What is it? R minus 3 squared. Good, we've got that pattern down. Equals 11. What do we do now? Square root both sides. We have r minus 3 equals plus or minus radical 11. How do I finish? Add 3, r equals 3 plus or minus radical 11. You got it? All right, we're building. It's going to get harder. Let's do the next one. All right, so on this one, this is not in any kind of form. There's nothing you can do right now to solve this problem. I have to distribute it first. I get y squared plus y. I'm going to leave some space because I have to complete that square. You see what I did? I distributed. I'm going to add that value here, and I'm going to add that value here. Some people like to actually put the blanks because now it's like you're filling in the blanks. What's the coefficient of y? If I take half of it, I get a half. What is 1/2 squared? 1/4, right? 1/4. So if I add 1/4 here, I add 1/4 here. I have to do what to the both to the same both additions to each side. All right, let's go slow on this one as far as factoring this. I need to set up my double parentheses. I've got y and y. What numbers multiply to be 1/4? Is it 1/8 times 1/8? 1/8 times 1/8 is 1/64. 1/2 times 1/2 is 1/4. Okay, let's do that. 1/2 and 1/2. While we're at it, what is 3/4 plus 1/4? 1 whole, right? What are these signs going to be in order to get 1 whole y? Plus and plus. Now, I've got this, so another name for that is y plus 1/2 quantity squared equals 1. I'm going to stop talking, see if you can finish it on your own. I'll be finishing it up here. How'd you do? Did you get it? Questions? Make sure you ask if you don't understand something. All right, let's keep going. All right, explain how the expression 4p plus 1 quantity squared, let's wait on this one. If you understand what's going on, you can be thinking about this one, but I'm going to come back to it in a minute. I want to finish these first. Determine whether you would use factoring, square roots, or completing the square to solve the equation. Then solve it. Here's the thing, guys. We have all these methods to solve problems. We want to do things the easiest way. I will never tell you you have to solve a problem a certain way, because you need to do what's the fastest, easiest way. Number 9 here. What do you guys want to do to solve it quickly? Do you want to factor? Do you want to use square roots or completing the square? There's no wrong answer. It's just you got to make a decision. Drew, choose one. Factoring square roots or completing the square? Okay. If I'm going to use factoring, it's already set equal to 0, so that is a good choice. If it's not set equal to 0, then it's not a good choice. With factoring, I would look for a GCF. What's the GCF here? Yeah, but specifically, what is the greatest common factor? What can I factor out of these two? X. So I can take out an X. What is X squared divided by X? X plus, what's 7X divided by X? So now I have it factored and set equal to 0. Having it factored and set equal to any other number is not good. If this had been a 5, this would have been the wrong method to use. But the way it is, I can do this. So I have two factors, they're multiplying, they're equaling 0, so X has to be 0 or X plus 7 has to be 0. So one of my solutions is 0. My other solution is -7. So that was a good choice. I could have done this by completing the square. I could have taken half of 7, 7 halves, square it 49/4, added that to both sides, gone through. You would have gotten the same answer, but it would have been pretty difficult, wouldn't it? So this was the better choice. All right, what about this, guys? What do you think? Square roots, yeah, take the square root of both sides. So now I'm going to have x minus 1 equals plus or minus. Can I simplify square root of 35? 7 times 5? Nope. So just got to leave it. And then add our 1 to both sides. Remember to keep that whole number first and then the irrational part second. And that's the best answer there. All right, what about number 11? What could we do first to number 11 just to make it easy? I wouldn't say subtract 12 necessarily makes it easier. There's something that I can do if I look at these numbers. What is it, Gianna?
Like 4 parentheses x squared minus plus 2x plus 3.
I can do that, but I'm also allowed, since it's equal to 0, I can always divide by any number I want to. Just like I can multiply by any number I want to, I can divide. So what should I divide every number by to make this easier? 4. So let's do that. Divide the first by 4, the second by 4, and the third by 4. Now it's an easier problem. Now guys, you cannot divide by x. Why? Why are you allowed to divide by 4 but not x? X is a variable. It can be anything. So you are getting rid of one of your answers. So I can divide through by constants but not by variables. Like somebody back here, you might have said divide by x. Well, then you're going to lose that solution. So you don't want to do that. All right, so back here, what method now, you guys? What do you want to do? What did you say, Hamza? I don't think it is a perfect square right now, though. Do you want to do completing the square? Okay. Subtract 3, subtract 3. So I have x squared plus 2x plus blank equals negative 3. And then I'm going to add something to both sides. What am I going to fill in, Hamza? What's half of 2 squared? So I'm going to put a 1 here, and I'm going to put a 1 here. So now I'm going to have, what's this going to become? Can you do it quickly for me? Hamza, stay with me on this one.
Thanks.
1 equals what? Good. Now what? Take the, right? And then we're going to have the square root of this is going to just be x plus 1 equals plus or minus. Okay, what's that going to become? Good. I radical 2. Subtract 1, and negative 1 plus or minus I radical 2. You know, when I first looked at this, I was thinking that he was actually not doing it the easiest way. But are there numbers that multiply to be 3 and add to be 2? No. 3 and 1 multiply to be 3, but they don't add to be 2, do they? Because when I first glanced at it, I was thinking it was minus 3, and then factoring would have been easier. Because if that would have been subtraction, then it would have worked for factoring. But that's our answer. Okay? All right, I want to stop there. We might come back to this one. This is a really nice challenge problem if you want to think about it. And get back with me tomorrow and learn how to factor it really quickly. We'll do that. Good job today, guys.